Welcome back to a Developer's Guide for Windows 10 Insider Preview. We're building adaptive apps that run against the Windows Universal Platform. Did I say that right? No.
You did.
The Universal Windows Platform. One of the most important things you'll add to your application is data. And one of the easiest and fastest ways you can start saving data is directly to the file system. .NET developers already know about isolated storage. The same concept follows through in Windows apps. And Andy, let's start with, where are the files?
Indeed, yeah. So it's kind of interesting because apps run within this sandbox and they have kind of an area of storage that's private to them, that's inaccessible to others.
Yep.
But there's also a lot of other areas that where they can get at files and interact. So it's probably worth just starting to looking at the locations where apps can access data. So here's our app sitting in its little sandbox.
Yes.
And the obvious first place where it gets stuff from is anything that's packaged in with it. So
this is what I install with the app.
That's right. So you could have read, and this is read only. So you can have files in there. You could have XML. You have images. You could have a SQL-like database. You know, you can have anything. You can have anything in there, but it's essentially in the app package folder, and you can get at that app package folder. Anything in there is read-only to your app.
Okay.
So for writable stuff, read-write, we've got three primary sets of folders. There's the local folder.
All right, so that's just a folder dedicated to my app on that machine.
Yep, it's and this kind of, think of it as like a little file system. You can create. It has a top level. You can create folders within it and create files within it. So it's a regular kind of file storage space.
How much quota do I have?
Local, no, unlimited.
That's right. That's right.
There's the roaming folder, which is interesting, which we're actually going to talk about a little bit in another module in a bit more detail. But essentially, that's just the same. It's still a file-structured set of storage, and you can read and write stuff into that. But the difference with the roaming folder is it gets synchronized across all of the user's devices where the same app is installed.
And my quota is?
So that's 100 kilobytes, 100 kilobytes.
Not gigantic.
Not gigantic. So it's good for sort of settings, preferences, that sort of thing. So you can store that sort of thing in there.
And so the temp folder, that last one, also doesn't have a quota, but you would use it for things that you know are transient, because the next time the user reboots, maybe that folder will be deleted by the operating system.
That's right.
You can't rely on it, but you can use it while your app is running.
Yeah, that's temporary storage. There's a new one in Windows 10 called the Publisher's Shared folder.
Ooh, nice.
So this one is a folder which any apps on a particular device from the same publisher, think of it like a file share. They can read and write files into this bit of storage that allows you to share stuff. So really nice situations for an enterprise LOB where you want to actually put some stuff and share it between different apps that you're creating as
a suite
a bunch of
assets like images, and you don't want to clutter up the users or take away the user's hard drive space by having multiple copies for every app they have. And your quota is?
Unlimited.
That's right. That's right.
We can use some removable storage, SD cards, and as a plug-in drive, so you can read and write to those. There's also something called the credential locker, which is a bit like roaming settings, but is specifically for credentials.
Yeah, it's very secure.
Encrypted, yeah. So you can store credential pairs in there and have those roam. That roams, well, as again, across different devices. So a really good way of storing stuff. So you only have to ask your user for their username and password once. You store it in the credential locker, and then you can then open your app on another device and not have to enter those credentials again.
And what's terrific about it is I don't have to implement encryption in order to just store a password.
No.
I can use something that's already part of Windows and I can rely on.
That's right. That's right. Right now, so up till now, that's kind of the roaming story, and we've been looking at the folders that you can get at, but there's actually a bunch of APIs called the File Open Save Picker APIs, which allow you to get at files outside of your sandbox and outside of the roamed folders. So this is kind of going out a bit further and allows you to get at files that are in, well, basically any location that is served by a picker provider app. And a typical example of that would be the OneDrive app, or the OneDrive for Business. It allows you to go and get apps that are stored in the cloud, files that are stored in the cloud, and read and write stuff to there. You can also get to folders such as the camera roll, My Documents, so the kind of traditional locations are also available.
Any folder on your hard drive, as well as remote locations that are enabled by something else like OneDrive.
That's right, yeah.
Okay.
It's gated through this, and we're going to look at those in a bit more detail. And then finally, there's a bunch of APIs called the known folder. Well, not finally, but there's a bunch of APIs called the known folders, which, again, go to these kind of common locations, such as my pictures, my videos, and my music, my documents, this sort of thing. Allows you direct access to those locations.
Okay, so they're on my hard drive, but I don't have to use a picker to access them.
No.
I immediately have access. Otherwise, I'm inside my sandbox, and I can't talk to the hard drive.
No, that's right. And the difference between the two, and we'll talk about this a bit some more, but known folders, you declare in the manifest, I want to get at pictures or something. So the installer or app knows up front, it says this app needs access to your pictures or something.
Right.
And so they can make a decision at install time whether they want to install that app. But those known folders are specifically gated to just those specific locations. Whereas the file open safe pickers is this open thing where the user can install an app which provides picker capabilities, which opens up,
got a box or
gives access,
something like that.
Exactly,
As well.
exactly. Gives you.
Now, I
access
feel like
to-
there's one missing.
There's a big one missing, and it is the cloud, of course. So we've got the cloud as being this other place, and this is obviously a key ingredient for having a continuous experience for your users of using your app using your app on different devices, and having a shared data and having that shared context that goes across and allows you to start a task on one device and then continue it on another. You're going to need some kind of cloud storage to restore the state, and there's a number of different ways. We've got another module we're going to talk about cloud, specifically about Azure mobile apps as being a great solution for that, a mobile backend as a service in the cloud. But you can use Azure or indeed other vendors' cloud facilities in order to store stuff in the cloud.
Okay, so one of the things I might do, I know, is ship information with my application. So that could be an initial database or something like you said, SQLite, but you said it was read-only. So what's the strategy for me to be able to leverage my package folder?
Yeah, so this picture here shows the kind of two logical theories you can think of for that. So when the user installs an app onto a target device, this thing called a package manager takes control of unpacking it all and storing it away into the folders where your app gets installed. You can install read-only stuff, and in many cases you can open a reference to those files and just read the content if that's all you want. If you want to modify that, then what you have to do is simply take a copy of it from the package folder and copy it into one of your the app data folders, and then you can manipulate it.
All right, that's a reasonable strategy. So I know that I can address all of these locations. Like, I know I can say $$ in order to get something. Can I say C:\\/ something? How do I access these files?
So this slide actually, it's something I kind of have it stuck to the wall because it's kind of, you always want to remember this, and it can be a little bit complicated.
Triple slash, not double slash.
Yeah, it's a weird syntax. But no, to answer your question, no, you can't use that. So there's a kind of a virtual file system within that the app looks at and looks at. So the installation folder, there's two ways of looking at it. There's a direct API access through the the application model.package.current.installed location. So that's the Windows.storage APIs. You get a storage folder reference back and a storage file objects, which are kind of
this is good for developers to know. They may be looking for system.io.file, and they're not going to find it. They're going to be using the storage APIs
Storage
instead.
APIs, that's right.
Okay, so you say installation folder to go ms-appx : that's the app package folder we were talking about?
That's right, yes. Yeah. So the two lines there, first of all, the top one is you can access, get that files using URI kind of syntax, and we have Windows.storage file, get file from application URI async. And that takes a URI. So here you use this ms-appx : / for the package folder, or ms-appdata : / local / or roaming / or temp / to get at the local folders.
As an aside, this syntax, XAML knows how to parse this syntax as well, and you can use it for images and things like that you might put inside your application. It knows how to go find those files.
Yeah, I mean, that's the classic place you'll see this is where you set the source of an image element in XAML, and if you've included a PNG or something in your package as content, you'll reference it in using the syntax source equals ms-appx : / file name.
So you as a developer might actually be able to get away with never using this syntax because you can go directly against the API, and that's what we see in that second
That's
row.
right. Yeah. Yeah, so there is a bunch of different areas where you can directly access. So just another way of looking at the same thing, how you can access this read-write data storage. So this Windows.storage application data, we've got the roaming folder and settings, the local folder and settings, the temp folder, which might be cleared up anytime.
Not while you're running.
Not while you're running, no, in between. There's the publisher cache folder we talked about, which is this shared kind of file share for all the apps installed on a device from the same publisher. And then you've got the password vault, the credential locker.
Now, there's one column missing in your graphic, and that is the local cache. And so it works just like, doesn't have settings, it's only a folder, but it works just like local, with the exception of when I am backing up my user profile, it does not get included. So I may have to interact with a lot of files, but the reality is if the user needs to refresh Windows, they could start over and replace these files. I don't want to fill up their backup, so I can put it in the local cache.
Yeah, so that's a good perf win potentially. Right, just a little bit of basics. If you're new to Windows.storage, it's worth just running through just so you kind of get a feel for it. Here isn't a simple example of how you might write some text to a file. First of all, the pattern is always you first of all need to get a storage folder reference, which is kind of a pointer to the top level folder.
Like you said, you can't use C:/. You don't know where this folder is going to end up. You have to ask where it is first.
So here we're getting a reference to the windows.storage.application-data.current.local folder. So that is the root of your local folder, the local storage, file storage on your device.
Create file async, and so this will be different for developers as well because it's asynchronous. All file operations are asynchronous. So if you're going to do something to a file, you're going to need an async method, which, for things like suspend, you're going to need a deferral.
That's right. So, again, this is something for you. If you're coming from sort of traditional .NET, you've obviously got async in that. But what you'll find in the UWP Windows.storage APIs is that any API that has the potential to take more than, is it 50 milliseconds?
That's right.
To execute, there's only an async version of it. So in full .NET, you might find synchronous file access APIs. But in this, it's all going to be async.
We've all carelessly locked up our UIs before.
We have. It's a whole topic of a whole MVA.
All right, so that was writing a file. We also know, of course, we can read from a file. Let's look at that syntax.
Yeah, so here's the reverse, if you like, reading the text back, very similar pattern. Get your reference to your storage, get your storage folder reference, and then there's the get file async. One interesting thing about this, there isn't a does file exist API. So typically you have to, if you want to find out if a file actually exists, you have to get file async, and not shown on this slide. You have to catch the file not found exception. That's the way. That's the only way of actually logically finding if a file is there or not.
Funny, I think that's funny.
It does. It's always struck me as odd. There's a missing API there.
By the way, you aren't getting a stream back. You're getting a random access stream, and certainly this is a type of stream that developers new to this platform, you've never seen anything quite like it, and so manipulating it is a little bit of a trick, but you'll get used to it. So I saw in your graphic, I could access, in local at least, I could access folders, but I also had this idea of settings.
Yep. So both local folder and the roaming folder have both this file-based storage, but also both of them have a settings dictionary, which is just a string object dictionary. I was trying to say object. We say object, but
sure that
it has to be
serializable.
Something that's serializable to a string, effectively. So so the object needs to be serializable. The workaround, by the way, is if you're trying to store an object in there that it can't serialize, and you'll get an exception if you can't, you can use something like JSON.NET usually. Serialize it yourself into a string and then store that in the settings. But this is kind of the pattern of using the local settings. The roaming settings is exactly the same. You simply can. It's just a key dictionary.
Yes.
So you can store any old objects in that.
So easy to use.
Yeah, very easy
What's
to use.
What's important about this is if the user closes your application and loads it back up, all of your local settings are going to be preserved, so you can just read them again. It has nothing to do with the session that you're in. And this probably is a good segue to talk about roaming settings.
Indeed, yes. So the roaming settings and the roaming folder, like I said, the roaming settings works just the same as local settings. But the beauty of this is that, the beauty and the potential downside, the beauty of it is that it allows you to synchronize across different devices.
Yeah.
So this is really important. I can't emphasize this enough in creating a continuous experience. These are kind of the delighters for users of your apps, that they set, maybe you've got a color preference, and you set it on one machine, and then on the phone, for example, maybe you like, I don't know, white text on a green background, to use a silly example. And then you go off and you launch the app on your tablet, and hey, look at that! It's already white text on a green background.
You know what? This is the expectation that a user has too. They come into a sports app, and they're going to want to set who their favorite cricket team is.
Yep.
Thought you'd like that.
Thank you.
And they don't want to go then run your application on a phone, and it asks who's your favorite cricket team. I just told you, and so the roaming kind of solves that problem.
And that was kind of irritating to a user if they have to enter stuff all over again. So
if there is a conflict, by the way, it's last in wins. Whoever is the last to write overwrites all of the others.
Yeah, and it's worth just stressing that there is this sync limit of 100 kilobytes for the amount of data for apps acquired from the consumer store. If you exceed that, it doesn't break your app.
You don't get an error.
You don't get an error. It's just syncing stops.
Yeah.
And then it starts behaving just the same as the local folder and local settings. So your app doesn't break, but that synchronization bit breaks.
Okay, so we talked about reading and writing from a file. We talked about reading and writing our settings, even roaming our settings across devices. And then there was the credential locker.
Yeah, credential locker. So this is real nice. This is the otherwise known as the password vault. It's another string key dictionary. So we're going to take another look at this in a module that we may or may not get around to doing this time around, called Connected Experiences. It will happen one day. But yeah, we're going to deep dive on this. So it's very easy to use though. So again, it's just another dictionary. You give it a key, but this time you store in it password credential objects. So a username and password pair. So again, this is another one of those delighters, and the user can enter credentials just the one time, and it becomes available. It gets synchronized across all of their devices.
And so you read and write as if it's a simple dictionary. What's nice is on the back side of it, actually where it's stored, it's rock solid and completely secure.
Yeah, that's right. It's easy to use, and as Jerry says, very cool.
It's made of unobtainium.
Unobtainium.
It's absolutely impervious.
All right, so let's go and have a look at and now a demo storing stuff in a file is kind of pretty dull, really. So actually, we're going to delve a little bit into nice patterns. So how you might do this with a little bit. We're going to have a little dose of proper architecture into this.
Well, look at that! It's our to-do app from Template 10.
It's a to-do app, yeah. So let's just run it, and it's the to-do. It's a variant of the to-do app, Template 10, and I'm just going to run this up on the local machine, and not surprisingly, we can add to-do items. So here's a guy. We can rename him and say, okay, let's call this MVA stuff. So we're good on that, and then we can start adding a task.
Folders. Learn about folders.
Oh, okay. Learn.
Oh, that's nice.
Folders.
Good.
Yeah.
That's how you spell it in England.
Yeah, indeed. So there you go. So and of course, if we close it,
yes,
and then run it again, and I'm just hoping that I actually fixed this version.
Well,
and yeah, there we go.
We did learn about folders. You can check that off. Apparently, we did.
All right, good. There we go. So there we go. Good stuff. Now, how did that work? So actually, let's just walk through how the code. I'm going to just set a breakpoint, and then we're just going to walk through so that we can see. Here's the execute load command. So this is what happens. This is in our view model. So this load command is called from actually when we navigate to the page. Where we go on navigated to, we're going to execute our load command. I've set the breakpoint. Let's run it and just walk through so you can just see how, in a nice architecture, how we can make this work. So here we go. We're going off to. We're using something called the repository pattern here. So we've got a nice repository, which what it does is it encapsulates
all the responsibility for reading and writing, basically.
Yeah, thank you. So we've got methods in here like get async, get all of the to-do list items, a list of to-do lists. So we get them all, or you can get a specific one by a key. And the important one is get async. We've got a file service we're going to use in a minute that helps us to do this sort of thing. We've got a factory method to create a new instance. which is what happened when we added a new item. We can clone them. And this is the sample data, which actually is used on some of the ones where you launch it, the sample, and it's already got some stuff in it.
Good for design time, too.
Exactly, yes. So stepping into this, and we can dive into this is our file service, which helps us to actually read the stuff out of our file. And we're using our file helper to read the file. Here we are in read file async. So this is where we actually start doing stuff with the file system.
We wrote this file helper all the way back to Windows 8. The APIs remained consistent the whole time.
Which is a good message, actually. This is 8.0 code, works absolutely perfect in UWP.
Yeah, that's right.
Here we are. This is get if file exists. I said there was no file exists method. So actually in here, this is what I was saying. It allows you to choose where you can store it. And basically, we're using the get file async API, and we're simply just trying to get a reference to it and catching the file not found exception if it doesn't exist, and that allows us to return true or false. So that's kind of that.
Basically, creating our own does exist, or file exists.
This says, yes, we've actually got a file exists, and now we can read. We're using the Windows.storage file IO read text async method. So we're just reading the text, and actually what we've got stored in there is a bunch of.json. So that is our object model. This is all the data for our app at the moment.
This is what you saved it as when you left the app before.
And so we've got a deserialize method in here, which actually uses JSON.NET just to deserialize that from JSON back into the objects we've got. And that's essentially it. So it's a nice pattern, and this is obviously up on GitHub with the rest of our samples. So if this works for you, you can use a nice repository pattern like this. And that's
everybody uses a repository pattern.
I hope they do. If you're
it's
not,
different than
the
suppository pattern. That's not the same.
Thank you for that. I can see.
Not for storing.
I can feel a cut coming on there. All right. Thanks for that, Jerry.
Not cut to us. We're busy blushing.
That's why
All right. Well, anyway, so that's perfect. That's a great use of the file to be able to serialize, deserialize your data. Just save it to a file and it's there. If your data is small enough, you could even put it in the roaming folder, but be careful, 100K comes very quickly, and suddenly it's not going to roam, and you're not going to get a notice that it's not roaming either.
No,
so it's probably not a safe way to do it.
No, and the other big problem is that you're at the mercy, the synchronization is non-deterministic, so it's last writer wins. So yeah, if you do save some new to-do items on one device, and then you quickly go to a different device and pick it up, and it hasn't synced yet, and you create you create slightly different ones, and then you end up overwriting. So it's really not, the roaming data folder is really not a safe solution for sharing data. You really got to use something in the cloud for that.
And so it's neat that the publisher has the ability then to have multiple apps and to share the data across all of those apps. So apps from the same publisher can share files and settings, and so that's quite a capability.
So yeah, I mentioned this a couple of times, but it's just to tell you how you use this. So it is just a shared folder. You use storage folder and storage file references to access the files in it, just the same as if it was in local data or roaming data. But there's a little bit...
With the exception of the root.
With the exception of the root. So the way that you can declare that you want to access the publisher cache folder, you have to put this into your manifest. And you have to put it in the extension section. There'll be some other stuff in there, quite likely. And you have to put an extension in there for the category of Windows.publisher cache folder. And inside that, you have a child element of publisher cache folder. And then you must specify a folder.
And does that name needs to match something, or where do you put?
Well, no. So you can put more than one of these folders. And what you're effectively doing is declaring these are the root folders that I'm going to use. And so you could have more. So what we're saying here is I've got a folder called folder 1 in the publisher cache folder I'm going to be accessing.
Do I have to create it?
No, you don't. So all you have to do is put this in here, and it will be automatically created for you first time you access it.
So here's another great example. If I'm using shared storage, one of the things I might want to share are the fonts or that type of access, or that sort of asset that I might have.
Yeah.
So this is the syntax for accessing that. So I'm asking for that folder. I've obviously declared it like you showed, which means the system created the folder. It could be empty, but now I'm ready to write it.
Yeah. So exactly right. So now you get back a storage folder reference from that, and then you just work with it as if it was any other bit of storage. If you want to clear it, well, there's two ways of that. First of all, you can just wait for the user to uninstall the last app from you, the publisher, and then the system will automatically clear that out. Or if you want to explicitly clear it in code, there's a clear publisher cache folder async method.
Any of the apps that a publisher has can clear the publish cache.
Yep, that's right.
Yeah.
Yep. So there you go.
By the way, all of these folders are up inside the user's profile.
Yep.
And they are hidden from the user with the intention that the user can't go monkey with them.
No.
And so that's the way isolated storage kind of has always been. But it's worth not counting on that. It is possible for the user to go in and start tinkering with things. But generally, that's not the way it works.
Yeah, and certainly you can't on the phone, but actually the file system, you can actually on a desktop.
Yeah, you can.
Drill down.
You know how to change permissions and stuff.
Yeah, you do have to go in and, there's some well-known, it's not like it's secure or anything.
Now, you mentioned it to us earlier, this idea of known folders.
Yeah, so this is the idea that there are some known places where the user tends to store stuff.
Yeah.
And these are the known folders.
Like
So
documents.
Like documents. So we've got a whole bunch of APIs that expose these things. So it just simplifies this is what we call the user's data. It's their photos and their music and their documents and all this sort of stuff, which is the user's data. So this is a way of your app getting at some of that stuff. You have to declare in the manifest a capability, so that then this is exposed to the user when they install the app.
Interestingly enough, a user can go into their system and make changes to what these folders are and configure it themselves. Windows guesses when it's first installed, but of course the user is in control to make that change. You get, when you ask for this, the reason you don't specify the path and you ask for the path is because the user may have changed it.
That's right. And these known folders, they tracks those changes as well. So yeah, physically, these files could be sort of strewn in different places. But the pictures library, for example, could be set to be in CUs as public pictures or on an SD card as well. And what actually happens from when you use the known folders.pictures library get files async, you just get that amalgamated list of files. So it hides all the physical path away from you from your code. That's nice and easy.
So this is all about accessing users' content, but we want to make this clear that apps cannot do this until they declare the ability to do it and the user approves it.
Exactly. That's right. So yeah, this is where you have to declare the matching capability to say, yeah, I want to get the pictures or whatever.
Capability. That's what I meant to say. Yes.
Yeah. So in summary, that allows direct access to the user content folders, but you do need to declare those capabilities. The other one, if you like, doesn't need capabilities because the
it's all UI.
It's all and the user chooses where to go and open these files. So the permission is implied by the user simply exercising these APIs, and these are the file open save pickers.
So these are not unlike the pickers that we had in WPF, where I would launch the picker to go pick a file or something like that. What is a little bit different about it is not only it gives me the file back, it also gives me permission back.
Yeah. And also, these are sometimes called a contract. It's a file picker contract because it's very extensible. It's very open. So here we've got a picture of the kind of how it works, where your app is invoking a file open picker API, and then what happens next is that the shell, the device, if you like, Windows pops up some UI and says, okay, where do you want to pick from? And what it will give you is a list of valid places where you can be. And these are actually a list of apps that are file picker providers. So it will give you a list of, like photos or the phone or the OneDrive app and this kind of thing. And you just pick the relevant destination, whatever that can be. It could be an app. And then you go to the UI and select the file or select the location or whatever it is. And then that completes, and the shell Windows completes that operation for you, and then finally transferred comes back to your app.
So everything in the middle of that diagram, your app has nothing to do with. You're waiting for the user to finish this operation.
Exactly, yes. Yeah,
you can have the same flexibility that you had in WPF, where you can say start in this folder, only look at this file type, things like that. So you still have the nice kind of way to guide the user, but the user is the one doing everything.
That's right.
which is the way you want it because it returns back the permission to access, delete, edit those files.
Exactly, yeah. So the picker goals is that your app is kind of abstracted from this and doesn't have to care where the files come from or go to. It's very open. You can access all the same files in the same locations that the known folders APIs give you direct access to. But like I said, the permission is implied since the user is directing through the shell UI where we're going. You as the app, you don't have to care about this. So it's nice and flexible.
Not just picking a file, I could also pick a folder.
Yep, absolutely.
That'd
So
be
there's
fun.
file open. Yeah, there's a series of APIs in this. What does it look like? So here we go. This is an example of the file open picker. You can suggest some view modes and some locations, but actually the user has pretty much flexibility. You can filter the view of their folder, so it depends on the scenario. You could say, okay, we're inviting the user to go and find a picture to include in something.
Right.
So here we add some file type filters and say, yeah, I only want JPEGs and PNGs. And then you just call pick single file async. Windows Phone 8.1 developers will celebrate that line on the bottom of the slide. There used to be a different API for this. This was one of those differences between Phone 8.1 and
Continuation
Windows 8.1.
APIs.
The continuation APIs, which were brought in to handle, there were specific problems with the implementation of this on low memory devices.
Needless to say, our engineers fixed the problem
They
and
have
we
fixed the
dropped
problem.
the painful API.
They have fixed the problem, the painful API has gone away, and we're now converged back where we always wanted to be with pick single file async.
All right, so that's the way I can read a file, and then I can save a file. Feels a lot like the same syntax.
It certainly is.
I think I'd like to see it, though, maybe implemented in an application.
Okay, let's do that. So the file picker sample. This is yet again a new version of our beautiful to-do thing, but it's been slightly enhanced.
Okay.
So let's run this one.
I do love this to-do app. So simple.
Oh, it is. It is nice and useful. So this is a rather ugly version of it, but this is using the sample data. But now we can actually select a picture. So this is where we can go off and
That's nice.
we could take a new picture. There I am. So there we go.
Wow. Hey, look at that. It's
Yeah.
got the bars.
So it's
That's
not
what you
working.
really look like, Andy.
Yeah, that's right. So what's going on? Okay, there we go. And now we can select where we're going. I didn't really want to get into this. This is going directions that is painful to me. All right, okay. Yeah, there we go. Okay. And there we go. So the picture's gone in. Or we can go off to the file open picker, which is where I've got, happily, a little breakpoint here. And this is just the syntax. So now the file open picker, we new it up. We say I want thumbnails in the view mode. Go off to the pictures library, set some filters, and then we just call the file open picker pick single file async. I'm going to step, but actually what will happen when I step is we're back into the control of the file open picker. So this is the shell UI, which has gone off to the pictures hub. We're now out in the user data.
Yeah, this feels
and we
very
can
familiar.
Choose to put it is exactly the same. So now we're back in the app. So the shell's finished its stuff. We're back in the app. We're saying, have we got a file? If we have, then we copy it into our local folder. That's what we're doing. And we store the URI in our to-do model item. And there we
Well,
go.
presto.
And there it is.
Nice.
And
What would that to-do item be with that beautiful car? My
Yeah, if I had the time, I'd put a good description on it or something.
I'm sure you would.
Buy my next car or something. Steal my next car.
Oh,
Yeah.
Andy. All right, so earlier we were talking about I can access the folders, but I could also access things that are exposed by other applications.
Yeah.
So those are providers.
Yeah, so you can create a provider app. But what we think is actually, obviously, most people will be clients of this. So they'll use the file.
Like OneNote and
Exactly.
Box.
You'll want to say, yeah, so these are the people who expose cloud storage or some kind of file-based storage facility, whatever it is. So you might think of the next great thing that everybody has to have. But the greatest example of that, of course, is the OneDrive app. Not the greatest, but a fine example of a OneDrive app. So in order to create a provider picker app, well, there's techniques for that. We haven't got time to go into it here, but there's walkthroughs in the MSDN documentation. It's exactly the same for UWP as it ever was on 8.1, so you can follow the same techniques.
Makes sense to me. And all of those providers that are out there, they are automatically invoked for you. So if when the user goes in to get OneDrive or whatever, you don't have to specify that. It just happens for
That's
them
right.
for free. So that makes sense. So we're going through using providers, accessing the folders, but there's also this idea
This is something a lot of people miss with these things. So you have to start thinking about pickers. So the privileges associated with these files. Yeah.
Right.
Access rights. So the file pickers, nice and easy. They do allow easy access, and you saw how easy the code was. But think of a situation where, I don't know, a photo editor app where a user is doing some photo editing, and they're working away on a picture, and they think, oh, I'm going to kind of come back to that later, and they're editing it in situ. They close the app, they come back to it later on. What do you do how do you get the user to access this file, which, remember, is not in the app storage area, it's actually over in Pictures Library or something.
Right.
So you need to have a way of not have to ask them to go through the file open picker all over again.
That'd be annoying.
That would be annoying. So you want to be able to give them last time you were working on this, do you want to go and access it again, reopen the previous project or something, that sort of thing.
I see.
So that's what this access cache is all about, and it's kind of a necessary side capability to the file open pickers, and it's a way of managing this thing called access cache.storage application permissions. And it consists of two lists: a future access list and a most recently used list. All apps have these. They have a future access list which you can store these access permissions in. So the MRU is a list where it's a 25 item limit, and it's automatically managed. It's a last in, first out kind of stack thing. So you can just pop things onto this stack, and when it's filled up and the last time you accessed an item was more than 25 ago, it just drops off the bottom and you can't access it from there anymore. The other one, the future access list, you have to actively manage, but that is like a 1,000 item limit.
Right.
So you have to manage this. If you are hitting the limit, then A, you need to look at the logic of your app, and B, then you need to start removing items when the limit is reached.
So this would be where I have access to a file, and I want to have access to this file next time also.
Yeah.
And so I'd put it in the future access list dictionary.
Yeah. So here's a little code snippet, shows you basically what you do. So we're using our pick single file async, the same we do, and then when you get the file back, what you need to do is add that file, if you like, into the either or both of the most recently used list and the future access list. And thereafter, you can go and access that list, pull it out, and get a direct access back to that storage file again.
And adding things to the MRU is a way of influencing the UI that the user is using, so that they see that MRU showing up.
Yep, that's right.
All right, well, we talked about file management, basically our ability to read and to write information to the folders that are given to your application, but also the ability to access different types of folders that are available because I'm a member of a publisher family, or maybe because the user gives me access to those.
Yep.
Very powerful.
Yeah, a lot of sort of stuff there, a lot of detail. So I hope you know your way around file storage now for UWP apps. And of course, it's much the same, but there's a few new features. The publisher access cache is new for 10. The rest of it is same old as if we've been using it 8.1.
So we're going to take a break here, and you can go and get yourself a meal. Maybe you'd like to get a little snack. We will take a few minutes here, come back, and start up with more stuff.
More stuff. See you soon.
See you soon.